Hello, everybody. I'm Thomas, and welcome back to another Software with Thomas stream. Today, we're going to be using the site Codecademy to learn some new languages, and specifically learn one called Lua. Lua is a general-purpose programming language used for building games, web apps, and developer tools. It's not a language I am familiar with in pretty much any way, so it'll be a new experience for me. This is going to be, it's a 4-hour course is what it estimates. I don't anticipate trying to do the whole thing today. I think usually those time estimates seem pretty accurate for my, for me trying the site out before. If anything, they seem a little bit on the longer side, but yeah, overall, we'll probably at least try to get through half of it. There's like 6 kind of core, sections. So we'll probably at least try to get through half of it. But yeah. Hope everybody's doing good. Hope everybody's had a good last week. I'm trying to think what I've been up to. Just been busy. I know today, I guess I should mention this up at the top, that today was supposed to be my Game Maker stream, but I'm pushing that back just because I want to get a little bit more familiar with it before I actually do a stream on it. So that'll actually probably be coming like here in a couple weeks, because next week I won't be streaming because I have some family stuff on next Tuesday. And then the Tuesday after that, I'll be playing Greyhack. It's my plan because I actually really want to play that game. I talked about it and I was supposed to play it before, and then I skipped that stream because of weather. So yeah, hopefully you have to figure out my schedule. I'm trying to get better at keeping a consistent schedule, which is, you know, what I anticipate is, the first stream of the month is web development, second is game development, and the last stream is like some game. So it'll probably be like the second stream of May is when I'll do Game Maker, which I'm looking forward to getting into. I've used it a little bit, not a whole lot, but like I said, I want to get a little bit more comfortable with it before doing the tutorial, which the tutorial doesn't look too long. I've done it before, but I want to get, some hours in on Game Maker just to make sure I know what I'm doing. So I don't run into any bugs, not have another Godot incident where I run into some bug and have to like figure it out off stream, then do another follow-up stream and all that stuff. But yeah, that's kind of my tentative plan for the next couple of streams. So yeah, and I'll go over this kind of at the end, because normally at the end I talk about my schedule. But yeah, no stream next week. Following week will probably be me playing Greyhack. The week after, I don't know what I'm doing, something web development related. Maybe I'll pop back onto Codecademy, do another course here. I don't know. And then the week after is when I'll do the Game Maker stream. But I think in May, I have some pretty cool stream ideas I want to do and for the following couple of months. So, I'm still getting started. This is still my first month of streaming. This is like my third stream, technically fourth, I guess, because Godot was like a two-parter. So I'm still getting the hang of stuff, still figuring out my schedule, all of that good stuff. But, we'll get it all smoothed out and figured out as we go. But I really enjoyed last week's stream, doing the Wordle clone. I thought was really cool, really fun. Turned out, I think, pretty good. We ran into that little bug at the end, but I think we fixed it pretty easily. I think the logic holds up good for like the checking the letters. And yeah, that was a fun one to do because I want to try my hand. There's a lot of those little daily games, stuff like Wordle was kind of like, I feel like the original. And then there's been like a whole spawn of like now these daily games that you could play just, once a day. New York Times has a bunch of them. They have like the mini crossword, connections, threads. There's Wordle, there's Worldle, like where you like guessing countries. There's Nerdle, that's like a math one. There's like Bandle, I think, is like a song one. There's all these other like daily games, which I think is a cool idea. And so I want to try my hand at making one sometime. I don't really have any great idea for one, so I need to think of a good idea, but I felt like doing that Wordle clone was a good way to, just do a fun little simple project and kind of get, started trying to make a daily game. So, yeah, I think that's pretty much all I got. Don't want to ramble on too long. Like I said, today will probably be a bit of a shorter stream. I'm guessing probably about 2 hours because I want to get through half of this, and it says it's a 4-hour course, so we should be looking at a little bit of a shorter stream, around 2 hours. And yeah, I guess before I get started, I'll real quick shout out if you're watching on Twitch, just so you know, I also have a YouTube channel that I live stream to as well. And the live streams will stay up on YouTube. I think currently on Twitch, they don't stay up just because my account's new, and I think it's just how Twitch does stuff, or maybe it's a setting I don't have, because I don't think any of my previous VODs are on Twitch, at least last time I checked. But you can find me at Software with Thomas on YouTube and Twitch, if you prefer one platform or the other, or if you just want to help me out and, follow me on Twitch and subscribe on YouTube, I'd appreciate it. Because I'm still getting the hang of this, still getting started, but I'm really enjoying doing this whole streaming thing, and looking forward to doing some cool projects here in the near future. But yeah, I just want to get that little thing out of the way, but let's get started. So for those that don't know, Codecademy is this really awesome site that's been around for forever. I mean, I remember using it at least 5-10 years ago, when I was like really starting to get out in programming, and it's still around and it's still come a long way. And it's basically just a site that has interactive lessons that help you learn some coding languages. There are a lot of free courses. There's also a lot of, you can get like a premium membership and get all the paid courses. So I did buy like a yearly premium membership at the beginning of this year. But today's course, this is just a free one. So this is one you can sign up for and do yourself. You can follow along at home and try to learn some Lua. I'll quickly show you the catalog because it's pretty impressive. What's cool is they also have these like course paths. So if you want to, a career path, you want to become a full stack engineer, this is 150 hours worth of courses where you go through and learn like fundamentals of HTML and CSS, developing locally, making websites, improving styles of CSS, JavaScript, GitHub, more interactive sites, more JavaScript, web apps, React, more GitHub, backend with Express. Like, it's a 150 hour course. And you do get like certifications, but they're just like, they're PDFs. It's kind of nice that you can get that, but it shows you, this will teach you JavaScript, Node, SQL, Express, React, TDD. I don't know if I know what TDD stands for. A lot of acronyms in software. Yeah, they have like these skill paths, these career paths, and then they just have a bunch of just language courses. You can see some of them are free, some of them are paid for. A lot of these are free, so either say free course or course. So you have stuff from, Lua, that's what we'll be doing today. Got React, Python, C#, Intro to Cybersecurity, JavaScript, command line, learning Go, more Python, Java, SQL, CSS, PHP. I'm a big fan of this site because it's not just like tutorials, but they're interactive tutorials. It'll give you a thing to do, and you have a code editor. You'll see as we start going through Lua, but it has different like little lessons along the way, and then normally at the end you do like small little projects in between lessons, and then sometimes you'll have quizzes to test your knowledge on what you've learned. So I think it's a great site. Like I said, I used this back in the day when I was first starting out learning coding, and I really liked it then, and I've been using it recently since I bought the yearly subscription, and I've still been really liking it. I go to my homepage, but you can see right now I'm in the middle. I actually just completed the learning jQuery course, which was quite good because I have never used jQuery, didn't know much about it. I didn't think it was like that great of a language at first. Like I was like, I've always heard of jQuery, but I'm like, what's it all about? Like, how good is it? And I was like, after I got through the course, I was like, man, jQuery is kind of awesome. Like for just the way it can like speed up a lot of stuff that you do in HTML and CSS. Like I think I might at some point in the future revisit and maybe do like another Wordle clone, but do it with some different languages. Like maybe I'll try doing it with like jQuery and TypeScript and something like that. Just adding in some extra languages and whatnot, I think would be a fun thing to do. So that's a little intro on Codecademy. But today we're learning Lua, which I said like before the description says is a general purpose programming language used for building games, web apps, and developer tools. And about this course. So Lua is a powerful and intuitive general-purpose programming language used for building games such as Roblox, World of Warcraft, and Angry Birds. I had no idea. Web apps such as Venmo and Adobe, and developer tools. This course for beginners will teach you the basics of programming with Lua language while giving you interactive practice building terminal-based programs. In this course, you'll learn a variety of basic programming skills using the Lua language. You'll learn how to write code in Codecademy's built-in code editor, add commas to your code, print messages in terminal, identify and use various data types, store data using variables, make decisions using conditional statements, and organize code using functions. This course is for beginners who are new to programming. No prerequisites, which is kind of nice. You can see a little course outline, and you can see each part has like, this introduction to Lua has, a lesson, and then you have quiz, project. This is lesson, quiz, project. So we'll be doing, like I said, I want to at least get through 3 of these. It looks like this first one isn't even, like it's probably just gonna be text, like not something actually to do. So maybe we'll try to get to like at least the condition and logic portion. But I mean, I've done my fair share of programming. I would not consider myself a beginner, so I might kind of go through this pretty quick. But I also, in programming, I feel like I've programmed a lot. I've been programming for a while, but Lua I have not messed with before, really ever. The one thing I know Lua is used for, obviously it looks like it's used for other things, like building games, web apps. The one thing I've used it for years and years ago was in modded Minecraft. There is a mod called ComputerCraft that adds computers to Minecraft that you can make programs for and make them do different things. And those computers in ComputerCraft use Lua. So long time ago, I learned a little bit of Lua to do a couple of things. If I learned Lua, I mean, I mainly just went online and found people's code and copied and pasted it. But yeah, let's get started. So welcome to Lua, a brief overview of what you will learn. In this course, you'll learn programming fundamentals with Lua syntax. The concepts covered in this course lay the foundations for using Lua in any environment. After this course, you will be able to utilize data types, built-in methods, and variables, use conditional logic to control the flow of a program in Lua, and construct functions and pass data through them. Learning is social, whether you're working Whatever you're working on, be sure to connect with Codecademy community in the forums. Remember to check in with the community regularly, yada, yada, yada. Okay, I don't care. What will you create? So throughout this course, you'll be tasked with applying the concepts learned in projects. So here's a preview of some of the projects featured in this course. The first one is this Mystic Moon Potion Shop. Build fluency in Lua fundamentals by practicing variables and printing to the console to create a receipt program for a Mystic Moon Potion Shop. Then we'll have a Magic 8-Ball. So you could practice control flow to build out a flexible program that tells fortunes. And then finally, get a Fahrenheit converter. Practice functions by writing a program that converts degrees to Fahrenheit, or in Fahrenheit to Celsius or Kelvin. And that's the first little part. So now we're gonna actually get into doing some coding. How about that? Should say, hopefully maybe I should move my camera. I guess, I don't know how much it'll be covering. I'm gonna keep it down there for now. I might move it to the top right. I don't know, I'll have to kind of just gauge it as I go, because I know like the code editor will be here. Top right might be better actually, but we'll see. I'll have to move it if it comes up. So, introduction to Lua. So Lua is a powerful and intuitive general purpose programming language developed in 1993 by a team of scrappy professors at Pontifical Catholic University in Rio de Janeiro in Brazil. Due to trade barrier on computer hardware and software at the time, the team couldn't buy software from outside their country, so they made their own. That's pretty cool. Many of the inspiration for Lua came from languages such as SOL, which doesn't stand for what you think, it stands for Simple Object Language, DEL, which is Data Entry Language, and in Portuguese, Sol means sun, and Lua means moon. Despite its humble beginnings, Lua is now used for building games such as Roblox, World of Warcraft, and Angry Birds, web apps such as Venmo and Adobe, and developer tools such as Redis, which I've heard of that. Is that something related to React, I think? I'm curious, what does this link tell me about? That's cool. I didn't know it was used for like World of Warcraft. That seems kind of a, what is it, showcase? Will that tell me that? To customize their game interface. Interesting. Nmap, okay, I've heard of that. Adobe Lightroom is mostly written in Lua. Wireshark, I definitely know of that. Popular Network Protocol Analyzer is scriptable with Lua. Okay, so it's maybe not written in it, but you can do stuff with it. That's pretty cool. Okay. Lua has easy to read Python-like syntax. Ooh, that's cool. I like Python. I don't get to use it very often on my day-to-day. I'm mainly a web developer, so I don't get to use Python much, but I do appreciate it, and it's very readable, so that's cool. It takes up very little space on your machine, and it can interpolate with any C code. And this lesson will start by learning the basic fundamentals of Lua. Happy coding. Yeah, I think my camera, I might move it. We're gonna go, I don't know, bottom right maybe. I don't know where I'm gonna be blocking not a lot of stuff. We'll go down there for now, and if I'm still in the way, we'll figure it out. But I think top right, like this is gonna be the terminal output, so that might also be blocking stuff. And then over here is this, so we'll chill down here for now, and I'll move it if I need to. Introduction to Lua. Of course, we're gonna start with a good old hello world. So take a minute, take a look at the main.lua file in the code editor. It's a Lua program. When learning a language, tradition suggests that our first program prints to the screen hello world. I feel like that tracks. In this case, it could be done in a single line, print, and in parentheses and quotes, hello world. Everything inside the double quotes will be printed to the terminal. The terminal is a window that allows people to interact with a computer program. It's a blank screen on the right. It should be blank now, but we'll change that in a moment. Don't worry if you don't understand something. Everything introduced in this lesson explained in the rest of the course. Well, there's not too much going on here right now, but it's fine. Whoa! Oh my goodness! It says hello world. I didn't even have to do anything. That's crazy. Okay. So, yeah, anything in the double quotes will be printed. We can also output multiple lines by doing multiple print statements. Makes sense. Notice how the order of the print statement matches the order of the code, because Lua reads from top to bottom. Makes sense. Let's use what we learned so far to complete a coding challenge. Instead of displaying those two lines in the code editor, edit those lines so that it'll output the following pattern in the terminal. It needs to look something like this, exactly how it is. And you can see, if I just try to click like run, we get a big old X. So like this checks, along the way that, okay, I didn't do at all what it said. So we just need to like probably an easier way to do this, but we're gonna do it like this. And just, I guess there's like a space between these. Okay, we're probably gonna need more spaces then. We're just gonna copy this. We need what, 4 lines? So then we need 4, 5, 6, 7, 8, 9, 10. That looks good. I think I'm 1 space off because they need to all be lined up. Something like that. We got a check mark. We're on our way. That's pretty good. All right, comments. Our code can quickly become difficult to understand when we return to it, sometimes only a few hours later. For this reason, it's often useful to leave comments or a reminder in our code for future selves or developers. Comments can explain what code is doing, leave instructions for developers using the code, or add any other useful annotation. A single line comment will comment out a single line. Whoa, who would have guessed? Is denoted by 2 dashes preceding it. You can also put a single line comment after some code. So let's practice adding a comment. Create a comment, a single line comment followed by your favorite emoji. Oh, well. Favorite emoji. I love the saluting, the 07 emoji. It's definitely my favorite. And then type print, and then quotes Codecademy. And submit. And whoa, our emoji's not there. That's crazy because it's a comment. All right, multi-line comments. So sometimes we have a section of our code that we want to temporarily disable. You do this by using comments to comment out those lines. We could just, put single line comments in front of all of those, but if we have a large number of lines to disable, going through each line, adding a single line comment would be tedious, and that's why multi-line comments exist, and they'll comment out multiple lines. Who would have guessed? It's denoted by double dashes and then double square brackets, and then more square brackets at the end. Let's practice commenting out an entire section of code. Currently, the program is set to self-destruct in 10 seconds. Not really. I'm glad they specified. I thought it was really going to explode here. So we got to use a multi-line comment, comment out the countdowns such that we see just starting program. I'm going to try something. Normally, if I just do like command comment, okay, that just does that. So that does single line comments, and that's not what we want. So we want double dash, double square brackets. Take these square brackets and throw them at the end. EZ. Okay, written a few Lua programs. You learned general purpose coding language. The code is read from top to bottom. Print is output to the terminal. Single line comments, double line comments. Before we go, let's write a letter to our future selves. In Lua, add the following goals for yourself, name and date. Okay. Do we add this as a comment? It says to just... Oh, okay. Yeah, we're supposed to just print it. Okay. Dear self, what was it? Goals for myself. Okay, well, learn Lua goodly. There we go. That's some proper English. And then print name and date. There we go. That's what it said to do. I did it. I don't think that's what they intended for me to do. Okay, so now you see we finished the first little section. So now we get a quiz, which should be pretty easy. Famous last words. What is shown in the below code snippet? Well, that looks like a multi-line comment to me, but that's not. Why are there double dashes at the end of the square brackets? That's not how it's. I don't know if that's how it's supposed to be done. I don't know if that matters though. I'm gonna go with multi-line comment, but I don't know if that's right. Okay, it is. Maybe I did it wrong before, but that's not how it showed before. What will output the program be? It'll just be without the quotes. That means world in Mandarin. Oh, hello world. Okay. Which one is the single line comment used? It's the double dash, easy. What should go in the blank to output the following a string in the terminal? So we're gonna go print and then just the parentheses. Super easy. Fill the code that prints the 3 lines in order: zeta, omega, alpha. This is a cakewalk. True or false? Lua is a general purpose programming language that can be used to develop games, web apps, and developer tools. True. Easy. 100%. Nailed it. And we're moving right along. Oh boy, block letters. And we could always take a peek at the syllabus. So this is the project for the intro section, and then we'll be on to the next part, which is variables and data, which we'll definitely get through all of that, and then maybe we'll see how far we get through the conditional part. Write a Lua called initials that displays the initials of your name in block letters such as shown. Okay. And what's nice is these will give you some step-by-steps. Well, normally. Take a complete look at the alphabet and find your initials. Okay, found them. We'll just go TS for Thomas Software. Okay, first step, we'll write a comment about a fun fact about yourself. What's a fun fact? I didn't know I was gonna be put on the spot like this. It's like, what's a fun fact? I can code. That is a fun fact. Let me tell you what. Output your first initials as block letters. Can I not just copy this? Oh man, I have to actually type it out. Oh, that's annoying. And we're just doing the, okay, and how many across is it? 5 and then the 3. So 1, 2, 3, 4, 5. And print space, space, T, whoa, space, space, T, space, space. And we need to do that 1, 2, 3, 4, 5, 6 times. Do the old copy and paste. 1, 2, 3, 4, 5. Okay. How we looking so far? That's a T. And then we need to output the second. And it looks like how it wants us to do it is do it right next to that, like that. So we don't want it to be underneath. So we need to add it to this input. Which we're gonna go with S. And that seems like it's actually gonna be not a hard one, but that's just a more complex one. Maybe we'll just go, yeah, we'll go S, whatever. So it's just space, SSS, space, space. I keep going to the wrong thing. So first we get space, SSS, space. Next is, I should just put this up on a different monitor, but whatever. It shouldn't take too long. S, space, 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 S. S, space, space, space. Oh, stop adding periods in there. Something like that, okay. Next line, it's just S with a bunch of spaces. S, 1, 2, 3, 4. Then we got space SSS. I can kind of almost figure this out just by guesstimating, but we'll do it this way. And then it's just reverse space, 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 S, space, or S, space, 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 S. Okay. So space, 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 S. That doesn't seem right. I missed a space. Okay. Then we go S, space, 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 S, final space, S, S, S. We did it! Whoa! That was kind of a weird project. It just has using prints. I feel like this was more work than it was just using prints, but whatever, whatever. Take a sip of coffee. Oh boy, here we go. All right, so data types and operations. All programs consist of data and operations. And operations we perform on that data. That makes data an essential thing you need to understand for your coding journey. In the real world, we use data every day to inform our decisions. We track data like how many eggs we have in our fridge so we know when to buy for next week, or we look up data on how many minutes it will take to get to work so we know when to leave for home. Moreover, data comes in more forms than just numbers. Sometimes data is more about what's true or isn't. Consider the weather. We either say statements of truth, like it is raining or it's not raining, when deciding when to bring an umbrella. We could represent these choices in terms of numbers. 0 means no rain, 1 means rain, but this isn't as intuitive of thinking of it about rain as either on or off. So having different forms of data allows us to better organize the information around us. In programming, the differentiation of data types is essential, Consider how a program like Google Calendar might use different types of data. It uses numbers to represent the numbers of attendance in a meeting, it uses text to display the title of a meeting, it uses true statements like this meeting is private to determine how new guests are invited. In this lesson, we will learn the different types of data in Lua, how to check the type of data, and how to manipulate data with operators. Let's go. Okay, so next, can you think of any categories in real life? No, I can't. You took them all. Okay, so categorizing data with types. So data is information stored by a computer. I can't talk. We need to even. I can't speak now. We need to write it even. We need to write to. I'm gonna take a sip of coffee. I'm clearly not awake yet. Let's retry that. Data is information stored by a computer. We need it to write even the simplest programs. The text you're reading right now is a piece of data stored on Codecademy server. As we learned in the intro, data can come in many forms. To stop the data from becoming a jumbled mess inside our computers, we must follow a system to organize and differentiate the data types. The organization is crucial because we can do different things with different data. For example, numbers and words have different purposes. There are actions you could do with numbers, you can't do with words, such as adding and subtracting. And words, meanwhile, are ideal for communicating thoughts and ideas. So in Lua, data can be organized into 4 basic data types, each with a distinct behavior and purpose. We got a number, numerical value, including positive values, negative values, and decimal values. You got strings, a sequence of individual characters. Inside a quotation, it could be letters, spaces, numbers, or symbols. Boolean, which is a value that has 2 possible values, true or false. And then we got nil, which is a representation of the absence of a value. There is no value, it is nil. There are also additional 4 complex data types that we won't go into now. They are tables, functions, user data, and threads. Interesting, okay. So let's practice using these data types. So first, print a number that represents how many languages you can speak into the output terminal. So we're just gonna do technically 2. Not very good, but I can technically speak 2. On a new line, print a string that represents your favorite movie to the output terminal. Favorite movie? I really like Interstellar. Is that stellar or stellar? I think it's stellar. Whatever. I don't even know how to spell my favorite movie, apparently. Whatever. That movie's great. I don't know if it's my favorite, but that's just the one that came to mind that I've somewhat watched recently and really enjoyed. On a new line, print a boolean that represents whether or not you ate breakfast this morning. No. Unless you consider coffee a breakfast, which I wouldn't. On a new line, print nil to the output terminal. Even though we see nil printed on the screen, it still represents the absence of a value. Cool stuff. Next up, we got strings and number syntax. So letters and numbers in real life are easy to differentiate, but in programming, there is more than meets the eye. So previously introduced the definition of string and number types. String could be created with double quotes or single quotes. Both of these strings are valid, so it's up to you whether you want to use. To include double quotes in your string, you have to use a / character in front of the character you want to include. Interesting. So since a string can contain numbers, letters, symbols, spaces, it makes string the most flexible type for representing any kind of data. However, does not mean we should represent every type of data with a string. Remember, categorizing data into types so we know what to do with them. So for instance, the string 100 is not the same as the number 100. They look similar, but they're not the same at all. The computer would interpret the string 100 as a combination of 3 characters, 100, rather than the number 100. Similarly, the Boolean true is distinct from the string true, just as nil is distinct from the nil value. So whenever you're not sure what type it is, you can use the type function or method. I guess I call it function here, to help you figure it out. That's pretty cool. So pick a number, use the type function, and print out the number. So we're gonna type Let's just do 42. It's a classic. Hitchhiker's Guide to the Galaxy. Meaning of life. Great. Modify the number in the code by putting matching quotes around it and run the code again. What happens? So we got 42, the number, and it says number. We put quotes around it. We run it again. Whoa, it's a string now. On a new line, print the type value of true. That's going to say Boolean. Oh boy, it does. And then we're going to put quotes around that. Run it again, and now it's a string. Crazy. So calculating with arithmetic operators. So it wouldn't be much for a program if we couldn't do something with all the data we collected. The fun comes from taking data and transforming it into something else. The most basic transformations are arithmetic. In fact, the first computers we created to automate mathematical calculations. Suppose we want to write a program that can estimate how far a car is from a place, or a program that calculates a user's shopping cart total. How can we make this possible? At the heart of it all are arithmetic operators. An operator is a special character that transforms data. Arithmetic operators are characters that can help us perform calculations such as addition, subtraction, multiplication, and more. And yeah, we can add, subtract, multiply, divide. That's all pretty self-explanatory. Exponentials, you can use the caret. Remainder, you just use the percent, and that gives you the remainder of two numbers. And negation, you just use a negative sign that reverses the value. So when we use operators to transform data, we call it an expression that evaluates to a new value. So the expression 5 plus 5 evaluates to 10. So Ian's shopping cart has two items, one priced at $10.95, the other at $20.99. Add these prices together on line 3 and print her total output to the terminal. Easy. So we'll do 10.95 plus 20.99. It's 31.94. Luca's ice cream store has 300 ice cream cones. After a booming day of business, Luca was able to sell 298 cones. Use a subtraction operator on line 7 to print the statement on how many ice cream cones he has left to share with his friend Bruno. Okay. Bruno, is that a JoJo reference? I know it's not. Everything's a JoJo reference. All right, Billy charges $60 for a cowboy hat. Today he sold 49 hats, and they were all cowboy hats. Use multiplication on 11 to print the statement on how much money he made. So we're just taking the good old $60 times the 49 hats. Made $2,000. Billy is killing it on the hat game. Sage is holding a pizza party. Oh, is this a Valorant character? Sage is holding a pizza party for their friends. They bought 8 pizzas for $96. Use division operator. I thought they meant $96 each. I was like, that's some expensive pizza. Use the division operator on line 15 to create a print statement that displays how much one of Sage's pizzas costs. So we're gonna do 96 divided by 8. $12 per pizza. Then we got Caro promised Layla that she can have his leftover marbles. Caro has 7 marbles. He must divide among 2 friends. So we use the modulo operator on line 19. It displays how many marbles are left over after dividing for Layla to keep. So we just do 7 modulo 2, and it's just going to be 1. Because that takes the remainder, essentially, is what modulo does. Hooray, you've reached the end of this lesson. Before you go, let's review what you earned. All that good stuff. Yeah, we're chugging along. I'm not going to really go over the review because we just went through all that. You know, there's no need to review it. Which of the following examples is a Boolean data value? That would be true. Fill in the blank with the correct arithmetic operator to complete the code such that the expression evaluates to 13. So we got 10, 8, and 5. So I think we just need to do 10 plus 8 is 18 minus 5. That's 13. Easy. How can you check the data type of any value by using type? What is data? That's a deep question. It's a character from Star Trek, isn't it? Information stored by a computer. Jeez. What is an expression in Lua? Oh, okay. We got a good question here. It's a window that allows people to interact with the computer program. No. Any code that resolves to a value. I think that's it. Rule that defines a structure of a programming language. No. A function to check data. No. It's definitely that one. Definitely. Which of the following is not a Lua data type? Nil is, Boolean is, string is, bytes is not. What data is best to represent the absence of a value? And that would be nil. That's what it's used for. What is the data type of the value? Whiteboards are remarkable. That would be string. Which of the following is an example of a number data value? Which would be 23. 60 sticky skeletons? That's not a number. Cool, we aced the quiz. I mean, this quiz is pretty easy. So far, the course is pretty easy so far. What are we on now? We're on to variables. Cool. How are we doing on time? Oh, we're only not even an hour in yet. We're cruising right along. Yeah, I think we'll definitely at least finish this and probably get through most of the conditional logic. And then, I don't know, maybe I'll probably just do functions off stream or something. Because I'll probably want to finish this course just to get my certificate and, you know, just to learn what there is to learn the basics of Lua. But this seems pretty... it seems like a pretty easy language so far, at least in my eyes. You know, it seems very similar to Python, not too far from something like JavaScript also. So, JavaScript I'm very familiar with. So, let's get into the introduction of variables. So far, our programs have only used values that we predetermined and hard-coded into our print statements. This means our programs will always print out the same thing every time. Most programs have more complex needs. For example, in a video game program, a player's health is constantly changing. We need something that allows us to track the health value and accurately display it. We should be able to change the value to reflect the player taking damage or healing during the game. We could try to hard code it like this, but this means we're assuming the health will always be 10, 100, or 95, or 90. And we know the data will change, but how it changes can vary. So ideally, we want to write player health ____, where the blanks represent the correct value during gameplay. So variables help us do this. Variables are named containers in the computer's memory that can help us store, retrieve, and manipulate data. A variable is akin to a labeled box. We can store we can store items of different kinds in a box and label it to help us know what's inside. Likewise, we can store data values of different data types into a variable and label it with various names. Using the variable names, we can access the data to either use it again or change the data inside. As we progress, you'll see why variables are powerful companions when we set our eyes on creating a grander programs. So in this lesson, in the ins and outs of variables by declaring variables, working with the data variables contained, and manipulating variables with arithmetic operators, reassignment, and concatenation. That's a bit of a tongue twister. All right, here we go. Defining variables. This should be easy, right? Variables help make programs changeable and adaptable. Without variables, it'd be impossible to create most programs. So suppose we are programming a score system for a game. Since the program needs to remember the current score and flexibility change it throughout the game, a variable can help us out. Suppose we have two players. We need to create two variables. So we call player 1 score equals 0, player 2 score equals 0. That's nice. That's nice and easy. Very Python-esque looking variable declaration. Not like some languages you got to put the variable type in front of it. So you got to do like let or const in JavaScript or var in some languages. I think you can also do that in JavaScript, but this is very Python where you don't have to just say it's a variable. You just do it. So you just do name equals value. Create two variables, assign them the value of 0 with the equal sign. But like scores in games, each variable's value will change as players earn points. Once we assign 0 to each variable, the variable names now represent 0, and we can access the values inside the variable by accessing the variable name. So rather than writing print 0, you can write print player 1 score. We should strive to name variables succinctly but descriptively, so when we look at them, it's easy to understand their purpose. For example, a variable named my_value doesn't tell us what kind of value the variable holds, but player 1 score gives us a lot more info. So our game's record keeping needs a little work. So let's expand on the data we're keeping track of. So declare a variable name called player1 name and assign it to the name of Kamala. We got the vice president playing some video games here. What's going on? Kamala, right? Yeah, Kamala, better. Player2 name, I'm just gonna copy and paste this because I am lazy. And change it to Bruno. No, I didn't spell Bruno right. Put Brun. Bruno, there we go. Declare a variable called highest score and set it equal to the nil value. Our game hasn't started yet, so there isn't highest score. There isn't a highest score, which checks out. Cool, we're cruising right along. Using type with variables. Phew. Data here, data there. Let's recalibrate a bit and think about what we've learned so far. We know that data is the building block of programs. To organize and differentiate data, we categorize it into data types. This helps us understand what we can and cannot do with the data that we have. Pop quiz. Recall each type and its definition, then click open each type to see how well you did. Number is just a number. I don't know what else. Oh, okay, that's what it wanted. Yeah. String is just sequence of numbers. That's true or false. That's nothing. It's a nil. Good job reviewing. That was easy. I kind of cheated. Becoming a Lua data type aficionado. If you want a bit more practice, revisit the lesson on data types. I don't. You know that variables can be used to store these different values. We'll let you in on another tidbit. Variables can store any type of data, and Lua has a familiar built-in function to discover what kind of data it's storing. Previously, we were able to use type to find the data type of our data values. We can also use type on variables. So let's create a variable called username and assign it to, we'll call that first, username, assign it to a value of a type string with any username you'd like. Oh, software with Thomas. Whoops, Thomas. Good username. Then we're going to print and type check the username variable. It's a string. Whoa. Make another variable called age. We're going to set it to 1000. That is my actual age, if you're wondering. That is 100% accurate. Do not call me old. And that's a number. Who would have guessed? Variable reassignment. So like boxes, variables are great containers for things. But what else can we do with boxes that we can also do with variables? Change the content inside. So after we've declared a variable and assigned it a value, we can change that value if we need to. The variable name will continue to represent that piece of data even after the data value has been changed. So going back to our scoring system code for our game, we created a highest score variable, which according to its name stores the number that represents the highest score, which we assigned with the initial value of nil, which represents the absence of a value as there's no highest score yet. But if a player does achieve the highest score, we can reassign it to the existing highest score variable, the highest score variable to a new value. Which you can see here will now be 25. And the reassignment just looks identical to creating a new variable. Highest score is printed on lines 2 and 5 with different values. Initially it's nil, then it's 25. Any code that includes a variable name will be working with a new value. Amazing. We can also assign the variables to the value of another variable like this. So legendary player score is 616. Highest score is legendary player score. Output highest score, and it's 616. Since variables in Lua do not have a type, it's just a container for value, and you can reassign a value of any data type to a variable. But be careful with this feature of Lua. Accidentally changing the type of variable is easy, can lead to trouble down the road. For example, highest score is 24. 24 plus 1 is 25. Highest score is now Kamala, and now highest score plus 1 is going to be an error because you can't add a number with a string. And that's just no good. Give me 1 second here. Okay. So, what are we doing here? While playing a game with Kamala, we managed to set a new high score at 25. Let's enshrine this achievement by keeping track of the high score's name. So we're going to declare a variable called highest score name and set it to Kamala. What? Did I make a typo? Yeah, it's highest scorer. See, it detects little things like that. It's pretty cool. I appreciate, I like, this is why I like Codecademy. It's not just like, it's not just like following like a blog post. It's pretty interactive, which I think is cool. Obviously, this is a pretty easy course. I'm hoping it gets a little bit trickier as we go along, but it's still fun to learn this. So then we will output this, which once again, I am lazy and I don't want to make another typo, so we'll just copy and paste. We got that. In a close match, Bruno managed to snatch away the highest score from Kamala's clutches. So without deleting the first line you wrote, on a new line, reassign the highest scorer name to Bruno. And then assign highest, whoops, I brought the double quote with me. Assigning highest score to 26. Good job, Bruno. So then we need to print the highest scorer name, and I assume we want to do this in 2 separate prints. We probably can do it in the same print with some concatenation, but I don't think that's what it wants us to do. No. Okay. Maybe we'll get to that here in a second. Okay. The compute part of a computer means we cannot leave what computers do best out of this lesson. We need to compute new values from our variables with arithmetic operators. So this is useful when we work with values that need to be numerically changed. Let's take a look at this in action. So we got player score 0, player score 1 equals player score 1 plus 1. And then the output is, well, 1. The syntax may look a bit strange at first. Let's break it down. Equals means we're assigning what's on the left to equal on the right. To understand this, we need to evaluate the expression on the right first, which player score plus 1, and then assign it to player score. So on the right, player score plus 1, we access player 1 scored, 0, replace player 1 score with the current value, we got 0 plus 1, which equals 1, and the equal assignment sets this back to player 1 score, so now we have a value of 1. It's just an easy way to increment the value. It starts out as 1 from the previous calculation. If we just add 1, now we're up to 2. And yeah, we could do this with addition, subtraction, multiplication, division, exponential, remainder, modulo, and negation. So in our game, Kamala has scored 1 point. Add 1 to the player 1 score variable and use print to output the modified player 1 score. So we're going to do player 1 score plus equals, oops, that's not it. Now we're doing, that might be possible, but that's not what it, plus 1. And then we're going to print player 1 score. And now we're at 11, starts at 10 hours out. Foul, Bruno loses 2 points. Bruno, bro, you're blowing it. Player 2 score equals player 2 score minus 2. I assume we want to output that as well. We do. Down to 8 points. Combo. Bruno gets a point multiplier. Multiply the player 2's points by 1.5 and use the print to analyze. So we're just going to, I don't know what happened there. I'm just going to copy this because I'm going to need that. And we're just doing player 2 score times 1.5. So we should get, I don't know, 12. I couldn't do that math fast enough before I pressed enter. All right, concatenation. This is good stuff. This is important to know. Thus far, we've manipulated variables with arithmetic operators or reassigned their values completely. We could also combine a value with another value to form a new string. Concatenation is the act of joining values, often strings and numbers, together. To do this, we use the concat operator, which is double dots. Observe the example below. Current player, the highest score is, and then dot dot, Bruno. And then that just gives a string. We concatenated 2 string values together to produce a larger string. Concatenation becomes useful when we need changeable or reusable output with different values. So once again, we got Bruno here as a variable, and then we can just concatenate that variable at the end. Pretty dang nice. Nothing too crazy, just kind of a weird way of doing it with the double dots, but that's just how you do it in Lua land, I guess. So the first part of our output will stay the same, but the second part will change based on high scorer names. Okay, so using string concatenation, combine the string of first player is with the variable of player 1 to print, and use print to print out the output. Okay, so print, just going to copy this because I am lazy. And we concatenate player one name. Whoops. There we go. We're just gonna copy that line down. The second player is player two name. It's Bruno. Bruno suddenly had to leave to feed his cat. Bruno gets his friend Nakia to take his place. Under the first print, reassign player two name to Nakia. Boom. Now we see a new output statement. Pretty cool. Type coercion in concatenation and arithmetic operators. So buckle in, put your thinking caps on, ready for a bit of a tricky challenge. So suppose we needed to use concatenation to make the results that mix different data types such as numbers and strings like this. What would the output be? Hold on to your answer. If you're just outputting a number concatenated to a string, it would be nice if it just converted to a string, but I assume that's not going to happen, and that's why they're saying put your thinking caps on. In Lua, these situations are handled by automatic type coercion. Type coercion is the conversion of a value from one type to another type. Lua does this automatically and converts the string to a number or a number to a string, depending on what is needed. So with type coercion, the number 25 will be coerced into a string data type. Thus, it will work with the concatenation operator and the string to produce the highest score is 25. Oh, it does work like that. That's good. Okay. It extends to the arithmetic operators too. So chew on this example for a bit. You get 100 plus 5. Take a guess what the output is. Is it going to be one? I think it's going to be one. Well, no, this is the arithmetic operator. If it was concatenation, that'd be different. But I think that's just going to be 105, right? Yeah, okay. Yeah, it does, because that just converts the string to that. Okay, for the last one, we have 105, and that's going to concatenate 6. So that's going to be 1056. Yeah, because it does the same thing, but then it just adds on the 6 to the end. It concatenates it, so cool. Not too crazy stuff going on. Makes sense. Yeah, as you can see from these examples, Lua's type conversion is a convenient tool that helps us deal with ambiguous expressions. However, it can get quite tricky. The answers may have not been what you expected, since it's not always clear how Lua interprets these expressions. I mean, I think it's kind of clear, personally, but I mean, I get it if it's not. If you want to be clear with our expressions, we can convert with functions to number and to string when we mix data types. Makes sense. We use toString to convert high score to a string, but the benefit is that we're now really being clear about what type coercion is happening. That's good. Oh man, sorry, stretch there for a second. Okay, so getting into the instructions. So using string concatenation, combine the strings player one score and the variable of player one score, and use that to just to print it out. So we'll do that. Do that. Dot dot. Keep almost wanting to do triple dots because that's like a JavaScript thing, but we're not in JavaScript land right now, are we? Okay, we need to do the same thing with player two score. Easy. Verify the type of your combined values by adding type function to the output of your previous two statements. Okay, I should be able to just do parentheses around that. I can. Thank you, Codecademy, for having a decent code editor. Not just like deleting stuff. There we go. Both strings. Great. Let's get a bit more comfortable with type coercion. Try to guess the output before running your code. Use the addition operator to combine player one and player two score and print it out. Try to guess the output is going to be 28. That's just it, right? Okay. So now I'm gonna use concatenation. So now we're gonna get 1,315 as the, yeah, it's easy. I like it. Okay. And we get a little end review, which I'm not really gonna go over because we just literally did all this, but good stuff. We're probably gonna get a quiz. So what do 2 strings and 2 numbers do? 2 number converts a number to a string. No, that's the opposite. 2 string converts a number to a string. 2 number converts a string to a number. Yes. Complete the Lua block so it concatenates the first variable and last variable together to produce the string notebook. So we need first ... last. Easy. What are variables used for Lua? For storing data. That's all it is. Fill in the code so that declares a variable named full name with the name Gabriela Garcia Marquez. Just full name equals. Cool. We got full name equal to Alan Turing. That's a name I recognize. Fill in the blanks to output the type of the variable full name. So we're just gonna do. We already have print, so we just need type parentheses full name close parentheses. Great. True or false? Lua variables can store values with a data type string, number, boolean. No. True. What will the following code snippet print out? 100 ... years of solitude. It should just print this, right? Yeah, it just converts the number to a string. That's definitely a bit. I had to think about that for a second, but I was like, it's not gonna convert that string to a number. That's not gonna work. So, Lua variable, true or false? Lua variables cannot be reassigned to a new value of a different type other than the one it had before. We're not in TypeScript land. That's false. Which, I mean, it's good for flexibility, but it's probably not good overall. But I mean, it is what it is. Which of the following is a valid way of updating the variable Dalmatians to the value 101? We have 91, so we just set Dalmatians equal to Dalmatians plus 10. Easy quiz, easy quiz. I've been acing all of these. Oh, here we go. We're doing the Mystic Moon Potion Shop. Greetings, travelers. Welcome to the Mystic Moon Potion Shop. As a fledgling new programmer in town, you've been enlisted to build a system to help the potion shop organize its operations. The Mystic Moon Potion Shop has a lot of information to keep track of: inventory, customers, prices, sales, employees, shipping, receiving, and on and on. Your task for this project is to create a system to generate receipts for each purchase. You will put together basic item information, the item total including tax, and display it in a receipt format. To complete the program, you'll be using the concepts you've practiced thus far in Lua, which is all this stuff. Let's get started. Yeah, the one thing is, projects don't run tests against your code. The experience is more open-ended, so if I wanted to, I could go through, just check all these boxes and then just be like, I'm done, but I'm not going to do that. I want to actually, try the project, learn something maybe. What a concept, right? Okay. Sorry, I just noticed my mic's picking up some background noise. I don't know if it's the music. There's no way you should be hearing the music. I have it low on my end. I have to adjust my mic settings at some point. Maybe it's too sensitive. I don't know. Not too worried about it at the moment. So to make a receipt, your system must know the information about each potion in the store, primarily its price, item, and description. These will come in handy when you need to calculate the total and print an itemized list for what the customer purchased. Let's start with the bestseller, the debug potion. So we're setting a variable named debug potion description, setting it equal to debug potion, an expulsion type potion, great for evicting bugs. I thought it said eviscerating, no, evicting bugs. Okay. The app also needs to keep track of the potion's price to calculate the cost and the taxes. So we got debug potion price and saying it equal to 404. That's a great price. Aha. Get it? Because 404 is not found. It's a good one. Good one, Codecademy. They're full of jokes. All right, so repeat the same process for the next 2 potions. Let's work on the loot potion. So we got loot potion description. I'm gonna just put a little break there so we get a little bit of breathing room between our potions. Whoop potion, a repetitive type potion, effective for menial tasks. And then we have Whoop potion price. If I can copy it, I don't know if that copied it. That copied the and. And that's just 222. And then we need to do the last one, which is bite potion description. And this is set to bite potion, a healing potion used to salve bites. Okay. And then we're doing bite potion price equal to 101. Let's just run this so far, even though there's nothing really to run. Okay. The Mystic Moon Potion Shop is a thriving business, but it needs to pay its dues to the kingdom. All customer purchases are subject to a 7% tax. Let's store that in a variable so the app can use it to calculate the taxes later. Dude, even in this mythical world, we still have to deal with taxes. We live in a gosh dang society, don't we? All right, let's store the tax value into the variable as well so you can add it to the total later. For now, set it at 0 since you don't know how much taxes will be. So create a variable called added tax and set it equal to big old 0. All right. Lastly, you need to keep track of the customer's total and the itemized list of things they've purchased, which might be a good thing for like an array, but we haven't really talked about arrays, which, is that a complex type? They mentioned tables earlier, and I don't know what, that would probably have to be like a list or like an array type thing. Hopefully we'll get to that. I feel like that's like a pretty crucial data type in my opinion. I mean, obviously we covered the basic ones, but I'm curious. Anyway, so declare a variable called, well, I cannot type, customer total. Set equal to 0. Customer hasn't bought anything yet, so it's 0. And then customer itemization set equal to an empty string. String will still store all item descriptions for items purchased. Yeah, it seems like a bad way to do it. It seems way better for like an array, but clearly we haven't like learned about those yet. They might not even be in Lua. They might be called something else. Okay, how far along are we? 18 steps. So we're almost like halfway. All right, we set up the variables, ready to produce our first receipt. It's time to open up shop. After being bugged by a particularly mean wasp outside, a customer stumbled in asking for one debug potion. Okay. The customer total should keep track of the customer's expenses. Add the price of the debug potion to the customer total. Customer total equals customer total plus, what was it, the debug potion price. I do wish this had some autocomplete, which I think for some courses it kind of does, but this one it clearly doesn't. Along with the item cost, you also need to keep track of the items the customer has purchased, so add the description of the debug potion to customer itemization. Which I don't know if we've really talked about that, but I'm pretty sure I could just do that with the itemization, then we concat it with the description. Something like that. Okay. Browsing the store shelves, the customer also wants to buy a bite potion. So add the price and the itemization. So I'm just gonna change this because I'm lazy. The bite potion. Bite potion. Let's display the second item under the first item using the /n character that indicates a new line. So concatenate that character between these two, which I imagine you can just chain concatenations like that. Even though we didn't really talk about that, but I just assume that's something you can do. All right, your customer is ready to check out. Finalize their purchase by computing the tax they owe and their new total. So we got to set added tax equal to customer total times, what would we call that? Sales tax, of course. And then we do customer total equals customer total plus added tax. All right, so now we're just on to displaying the receipt. So you can start by printing the receipt for your customers now. Let's start by adding a heading. Okay, to label what the customer is looking at. So start by printing the phrase customer items to the output. Done. What? I got an error somewhere. Did I make a typo? I did. There we go. I put SaleX tax instead of sales tax. My bad. Okay. Customers' items are stored inside of customer itemization. Print customer itemization. Hopefully I don't have more typos. Maybe I do somewhere. All right. There's the itemization. We see everything's on different lines, which is pretty nice. And then we want to add another heading and call it customer total. Lastly, we use the correct variable to print the customer's total for the purchase. You should now see a number for the customer's total, which I guess we'll just concatenate this for customer total. You can even like put a dollar sign there, even though it might not be in dollars. It might be in like gold or space gold or something. I don't know. Cool. And that checks out. They bought that one. That one should be... Wait, why is there a change amount? Oh, because of sales tax. Duh. I was like, that doesn't add up, but it does. Because that's... They bought these two, which is 505. And then 505 times 0.07. Let's see, 18.6. Is that right? That's got to be right. I assume it's right. Cool. There's some extra stuff that says you can try. I'm good. Want to hear about your experience? It's too bad. Wait till I'm done with this course there, Codecademy. All right, we're on to the logic section, which is probably be the last course part we'll do today. We're cruising along. We're only a little over an hour through this, and we've already gotten through at least the first couple parts, so pretty much right where I want it to be. What does the syllabus look like for this section? So we just got this part, a quiz, and then the Magic 8-Ball program is what we'll probably, the project is what we'll end on today. Oh man. Okay. Learning a lot. Yeah, so far Lua has been not too tricky, but looking forward to learning a bit more about some control structures, some conditions and logic. So, every day, we need to make decisions in our lives. We make these decisions based on current conditions. If we are hungry, we make food. If we have lettuce and dressing, we'll make a salad. If we're feeling lazy, we may eat at a restaurant. In a computer program, all of these decisions we can make it based on a question are called control structure. So in social media applications, a control structure might ask you, did the user sign up properly? And if they did, the program shows the user their account. And if they don't, the program asks them to try again. Control structures are made up of these conditional statements. A conditional statement is a piece of code that follows the pattern: if a condition is met, do X. So in a social media application, statement could be, if the user signs in is correct, then open the user account. Conditional statements can also be chained together to ask a follow-up question, covering any scenario that might come up. So if the user did not sign in correctly, the program could have them try again. However, if the user signs incorrectly 5 times, it may require the user to reset their password. So this will teach us how to set up control structures with Lua, write conditional statements using variables, and logic operators. So take a look at the picture on the right. The first condition asks the question, is it a weekday? With follow-up questions. Information like the current day and time are likely to be stored in the program using variables. We'll see in the next lesson. Take a moment to follow the code structure. What will you be doing today? Is it a weekday? Yes. Get up at 6:30. Is it raining? No. Don't wear a raincoat. Easy. Cool. The if statement. Here we go. The foundation of every control structure starts with an if statement. If statement requires 2 parts, a Boolean expression and a code block. The Boolean expression is just some variable that will evaluate to true or false, and a code block that executes if the Boolean value is true. Get it? If the Boolean value is true, that's why it's called if. So this says if is hungry equals true. If is hungry, then print I need food. Pretty self-explanatory. So it looks like we use if, the Boolean value, then we do then, and then we indent the code block, and then we write end. So definitely a bit different than some of the if statements. I mean, it really depends on the language you're using. You know, Python doesn't use like brackets, but it uses like colon, and then you don't have to write an end. But JavaScript, you need like curly braces, at least most of the time. I think you could do like a single line without. So it depends on the language, but this is definitely a bit different than I've seen. So use if, then, and an end at the end. Interesting. For now, our Boolean expressions will be variables that is either true or false. Later in the lesson, we'll get more interesting Boolean expressions that allow for complex control structures. Okay. So, create an if statement. If is sunny, then we print, what are we printing? It is sunny outside. It is sunny outside, exclamation point, back indent with an end. What's the weather like? It is true, so it is sunny outside. Add a print statement after the if statement that prints after the if statement. Okay, down here, I guess then, right? Is that what it's saying? I'm just gonna copy this. I'm so dang lazy. I don't care. I don't want to type it out, make a typo, and then have it yell at me, and then, whoops, I meant to do other stuff. Then go back to where is sunny initialized and change the value from true to false, and then run the program again. Okay, I'll run the resetting music. Man, I don't like this song. There we go. All right, comparison operators. So far, we use the most basic Boolean expression for if statements. Now it is time to do something a little bit more interesting. Often we need to compare two values to make a decision. For example, if the number of people in a room is greater than the number of chairs, we're going to need to get more chairs. In a Lua program, we can compare values with a handful of symbols we call comparison operators. So we have greater than, equal, less than, equal, double equals to check equality, and then tilde equals, that stands for doesn't equal. Once again, that's very interesting. It seems like most time doesn't equal is like written like exclamation point equals. Like that's usually not equal. So Lua definitely does stuff a little bit different than I'm used to. So I'm learning some stuff today, that's for sure. Yeah, they just compare the values and will either be true or false. So we're going to create a program that prints which value is greater. Create two variables with a equal to 5 and b equal to 10. Okay. Create an if statement that checks if a is greater than b. Then we're going to tab print a is larger. We have to add the end, of course. Just gonna copy this because once again I am lazy, and then we're gonna check if a is less than b. I guess technically, I mean it's the same thing, but it says if b is larger than a is what we're checking. Even though it's the same logically, like I just want to make sure I don't get yelled at by Codecademy here. We're gonna check if they're equal by doing a good old double equals and saying in the print that they are equal. And let's see what happens if we make them equal. Whoa, they're equal now. Whoa, b is larger. Whoa, a is larger. Cool. The else statement, here we go. This is where the if statement takes its, not final form, but starts getting actually a little bit more useful. So common scenario, we want something to happen if a condition is true, or we want something else to happen if the condition is false. We could write this, you know, if is hungry true, then I need food, else if it's false, I'm full, thanks. But you could just write it like this. You just write else, and then does the else part. And you just write the end at the end. That's pretty simple. I like it. Okay. Else statement code block cannot stand alone. It must follow an if statement that is paired with. A few other things to note: the else doesn't have its own Boolean expression. It relies on the if statement being false. You can only have one else for every if. The end keyword is moved down below the if, or the end of the else. Yeah. I'm going to create a program for grading an assignment based on a score. So create a variable called score, set equal to 90, then create an if statement that prints you've passed if the score is greater than or equal to 80. So greater than, score greater than or equal to 80. That's not 80, that's 80. Then print you passed. Got an extra quote in there. Sneaky little thing. We're gonna end this, but I think we're adding on to it, right? Did I do something wrong? Oh, I had like a space there. It didn't like that space, apparently. Now we're gonna create an else that prints you did not pass. Okay. Change the value to 79. Okay, you did not pass. Let's try 80. You passed. 81. You passed. Cool. Neat. Here we go. This is the good stuff. The else if or elif, depending on what language you're using. Imagine we're in the kitchen making a delicious sandwich, but we check the fridge and we notice that we don't have ham. So we don't just throw out the sandwich because we don't have ham. I mean, I would. If you don't have ham, what are you doing? First, we need to check if we have another option. Luckily, we have turkey and continue making the sandwich. So when creating a control structure, we often need more than just two options within our basic if-else. It's not enough. What we need is an option to check another Boolean expression if the first statement evaluates to false, and this is done with an else if, which is pretty self-explanatory, right? So people in the room 10, chairs in the room 5. If people in the room is 0, print no one showed up. Else, if people in the room is less than or equal to chairs in the room, we have enough chairs. Else, print we don't have enough chairs. It's very, very similar to if statement, but there are a couple differences. Else if must come after an if statement. We can enter as many else if statements in a single control structure as we like. Only if or else if condition statements whose booleans evaluate to true is executed. All other else if or else statements that follow are skipped. That's kind of a weird sentence, but pretty simple stuff, I think. Okay, so in this program, we're going to print out a different sentence based on what the user's score is using if, else if, else if, else. Control structure. We'll make 4 possible outputs. Okay, so if... Oh, we already defined score. I thought we had to do that, and we definitely don't need parentheses there. That's my bad. I guess I can also... It's probably a little bit late, but maybe I can make this a little bit bigger. Maybe I should have done this earlier. I realized the code is kind of small, but whatever. Better late than never, I guess, right? So if score equals 100, then we're going to print winner, chicken dinner. Is that really that good of a prize, a chicken dinner? I mean, I wouldn't complain if I got a chicken dinner, but like, why is that the phrase we use? Anyway, else if score is greater than 80, then print close but not close enough. I mean, that's on an 80. That's kind of messed up. If you did greater than an 80, that's what you get. Else if score is greater than or equal to 60, then print try again. And then finally, else print were you even playing? That's brutal. And then of course we have to add our end at the end. Play with the score value. Okay, so we get winner, chicken dinner. If we do 10, were you even playing? 90, 90 should give us the Close, but not close enough. 80, 79 should give us the try again. Yep, we're good. Cool. All right, logical operators. At every step of this lesson, we've been learning more tools that help us take complicated control structures and define them for a computer. Let's take it another step further. What happens when you need to pair conditional statements? I thought this was like a setup for a joke. What happens when you pair conditional statements? For example, if I am hungry and I have food, then I will cook. Using what we know, we can write nested control structures like this. So if is hungry and has food, cooking time. This code will only run if both are true. This works, but there's a better way. You can use logical operators. And the three are and, or, and not. These are all pretty self-explanatory, right? The and operator goes between two expressions, and both have to be true for the entire and operator to evaluate to true. If either side is false, it will not run. So if you're hungry and you have food, cooking time. The or operator needs only one of them to be true. So if it's either weekend or you're sick, you can sleep in. And then finally, the not operator has a different form from the last two. It only needs one Boolean expression and it inverts the value. So if not has correct login, then try signing in again. Good stuff. Okay. Write a program that grades test scores. However, the teacher handed out free pass cards earlier for participation in the lesson. If a student has a free pass, they get an A+. Press run to get started. Okay. Create two variables, score, set it equal to 100, and then has free pass and set it equal to true. Oops, I was supposed to do more. I got a little ahead of myself. Okay, then we're gonna create an if statement. Of if the score is equal to 100 or has free pass, you get an A+. So score equals 100 or has free pass, then you get an A+ will be printed. Good stuff. And we want to run the code, so let's throw an end, even though I know this isn't the end yet. Okay. Whoops. Add an else if. With a Boolean expression, if score is less than 100 and score is greater than, greater than or equal to 70, then print, whoops, I'll do double quotes just to stay consistent, you passed. And we can see you got an A, but if we do false, still got an A because we don't have a free pass anymore. But we got 10%, nothing happens. But if we have a score of 80, you passed comes up. So working great. We're chugging along. We're almost done with this part, and then we just have the quiz and then the magic 8-ball. So we're doing good on time. I think we'll be probably done and wrapping up here in the next like half hour or so. Okay, so now that we created even more complicated Boolean expressions, how does the computer know which to execute first? Well, Lua, like most programming languages, has an order of operations. Given a Boolean expression, it will evaluate certain operators before others. So this table shows what operators are evaluated first from top to bottom. So it goes, what was it? Why am I blanking on this? That's the power operator, but that's not what it's called, but whatever. The exponential, I was gonna say expression, I know. Exponential, then the not, multiplication, division, plus, minus, all the comparison operators, and then or. Okay, so take a look at this next example. Imagine you are playing a game where you must get exactly 100 points, no more, no less. If the score is anything other than 100 points, the program will print you did not get 100. We might write something like, if not score equals 100, then this. But given that the score is 50, what will output? Take a moment to think. So if not score equals 100, score equals 100 equals false. but this is not. So it'll say you didn't get 100, right? Yeah, it's not gonna be executed, but oh, because it does not score first before the equality, so this will always be if false equals 100, which will always be false, so you'll never actually get that inner part running. That's interesting. Okay, that's got it. So take a look at the code editor. There's a complex conditional statement that is pretty buggy. Use order of operations to predict whether or not the print statement will be executed, then hit run and see the code. So we have is hungry is false, cash is 5, friend is paying is true. If is hungry and cash is greater than 10 or friend is playing, then it prints the statement. Okay. So if is hungry, which is false, but cash is greater than 10, that's also false. Or friend is paying, and that's true. We are getting, I don't think this is gonna run. I don't think it will, but let's see. Oh, it does. Okay, well, now I'm confused. Let's break down the condition. We start with all of that. First, we evaluate cash as 10, which is false. Now we have that and that is false, but then we get that and that is a false, but then a false or friend, and that equals true. Okay, well, that makes sense. Okay. Well, changing the order of operations. So, as we've seen from last exercise, we need more tools to help us in our journey of making control statements. Hold on one second. Sorry. Okay. We are in WUC. There's a tool that controls the order of operations, and is the coveted parentheses. I was thinking that would help. Once we surround part of an expression in parentheses, we guarantee that part will be executed first before it gets used in another expression. So let's look at the same example as the last exercise, but with parentheses. If we add parentheses around this part, well, then it's definitely not going to be true, because even if this is false, even if this is true, they both have to be true because of and, so that's not going to run. There are times where the order of operations does not need to be changed for an expression, but using parentheses can improve readability of our code by more clearly separating expressions. Let's take another example of whose order of operations will work with or without parentheses. However, this example has a much better readability due to parentheses. I would agree. So it's detentions need to be greater than 0, and if your score is greater than 90 or has a free pass, then it gets a prize. You get a prize if your detentions is greater than 0? That can't be right. I think that maybe that's what they mean. I don't know. That doesn't seem, maybe they meant less than there. I don't know. Whatever. Okay, so using a single if statement, account for the following conditions. If it is not raining and the outside temperature is, okay, so we're doing not raining, or not is raining, my bad, I didn't even read the variable, and outside temp is greater than 80, or if outside temp is greater than 70 and not is cloudy, then that's quite the if statement. Then print that it is t-shirt weather. I don't know if I was supposed to use parentheses, but I did because it just makes more sense to me. Oh boy. Okay. We're adding an else statement to print wear a jacket. We can test our if statements by changing is raining, is cloudy, outside temp. I'm good. I think I get the gist of it. I'm just gonna skip over that. Amazing job. We learned a lot this lesson. Yeah, this is all the stuff we learned. Do a little review part, but I think I'm good. I get it. Let's do a quiz and then the final project. True or false? Using control structures, we can determine whether code block or not will be executed. Using control structures, we can determine. True? Yeah. Okay, that was kind of weirdly phrased, but I think I got it. What would this expression evaluate to? So 5 less than 10, that's true, and 14 divided by 2 is 7. 7 equals 7 true, so that would equal true? Yeah. Fill in the blanks, oh boy, here we go. 8 divided by 8 is 1, 7 times 49. So that equals true, so we got 1 plus 5, 1 plus 4 is 5. 5 is less than 49. Easy. What would this expression evaluate to? So we got hello equals hello would be false, or 7 does not equal 7. That's also false. Like just false, right? This is an XOR, so it's just a normal OR, so that's going to be false. Fill in the blank to make this statement correct. Blank evaluates a true or false. They're using conditional statements to determine if their blank executes. If statements and code blocks. I guess technically Boolean expressions is probably because that's what evaluates to true or false. The if statements. I don't know. This is kind of a weird question. It might be also if else statements. I'm going to do this. Okay. It was Boolean expressions. I think it's the code block is what. That was kind of a weird question. Using the provide code snippet, which will print, which print statement will execute? X equals 3 if X is greater than 4. No. X is not larger than 4. Yes. Thought that was like a trick question. Okay, fill in the blank. Control structures execute a single block of code based on one or more conditional statements. Got it. Based on the following code snippet, which print statement will execute? X is 8 if X is greater than 8. No. Else if X equals 8. Okay, X is equal to 8. There we go. Using the order of operations of Lua, determine which statement evaluates to true. Remember, this is the order of operations list. Oh god, this looks like a pain. Okay, well, parentheses will always go first, right? So this first line is going to be 9 divided by 9 is 1. 1 equals 1. This side is true. 2 equals 7. That's false. I mean, this first one evaluates to true, so I'm not even going to go through the rest. Dang it. What did I do wrong? Okay, well, that was the right answer. Man, I'm sucking at this quiz. Fill in the blank such that the statement evaluates true instead of false. So 7 divided by 7 equals 1. 1 equals 2 is false. We want it to be true, so we're doing not. Okay, he's got that one. Is New Year true? Okay, not my best quiz, but you know what? It still lets us go. I think if you like get enough wrong, it'll make you kind of do it again. Okay, we're gonna learn to implement control structures in Lua. Let's unlock the power of fortune telling. So we're gonna create a little magic 8-ball. It's got 10 steps. We should be able to breeze through this, and then we'll wrap up there for today with our little Lua tutorial. So, all right. In Magic 8-Ball, start by adding a variable that will store your name and call it name. Okay, simple enough. Done. Come up with a question. Create a variable called question that and assign a yes or no question to the question variable. This will be the question you want to be answered by the Magic 8-Ball. Will it rain today? Good question to know. Now you need a variable that will decide which fortune will be told. Create another variable called number, set it equal to random number between 1 and 5. We're gonna go lucky number 5. Choose wisely. This number will determine your future. Oh boy. You'll also need somewhere to store the fortune that you are printing. Create a variable called answer. For now, set it equal to an empty string. Okay, so just doing the initial setup. Great. Start creating the control structure that your app will use to pick the fortune. So create an if statement. If. And if number equals 1, then assign the string without a doubt to answer. I'm just going to copy that. You can get creative with your answers. I don't feel like it. So else if number equals 2, then I'm just going to copy this, paste it here, and then change it. So we're just doing the same, but for 2 through 5, we're just changing the answers around. It would be cool if they actually, I mean, I know we're still in the basics of this, but if they did like random number generation, 3, 4, whoops. Oh, now I'm gonna mess everything up. And then 5. So 3, 4, 5. This should be, oh, we already did that one. So the next one will be yes for 3. It must be so for 4. I can't say for sure, which is 5. You can also create an else statement in case some other number is entered. Answer equals, I really don't know, LOL. Why am I, get that out of here. All right. And then we also need to end. Oh, they gave us text to say. I'm not allowed to say. No, I'm sticking with mine. It's better. See if our code is running properly. First, create a print statement. That prints name dot dot asks dot dot question. Can't spell question. I guess they want it in like parentheses. Something like that. Okay. And then let's see our fortune. Print answer. Can't say for sure. Great job, Magic 8 Ball. There we go. All right, is that it? Are we done? I think we're done. Yes, we're on to the last part, which is introduction to functions. And I was gonna save that for another time. I don't plan on returning this. I'll probably just finish this on my own time. This is the last portion anyway. Take like an hour to go through. So I'll probably do this off stream just to finish up the course anyway. Felt like I'm learning a lot. But yeah, we're gonna wrap up there for today. So I will quickly hop to my just chatting screen. So I just chat for a hot second before hopping out of here. So I actually, I talked about that I might be not streaming next week. I actually might be. So I don't know for sure. It's kind of up in the air. If I do stream next week, it'll be Game Maker. If not, I might take next week off and then stream the following week where I'll be streaming some Gray Hat. But yeah, I had a lot of fun here today. Codecademy, I think, is a great site. They have lots of great courses. This is one of their free ones. They have a lot of free ones. They have a paid version that has a ton of paid courses. I have the paid version, and I think it's worth it personally, but obviously that's subjective based on, you know, how much you use it. You know, if you can, you know, pay for it and all that good stuff. So it's obviously subjective of if it's worth it, but I think it is. I think it's a great site to learn new languages because there's a lot of languages out there. I've never messed with Lua before today, and it's not too bad. Like it mentioned, it's kind of very similar to Python. I also see a lot of similarities to like JavaScript, but it's definitely closer to like something like Python. But yeah, I guess I'll probably finish the course offline, off stream at some point, just to finish it. But yeah, it was cool. Learned a lot. I don't know if I'll ever do something with Lua, but hey, now we could do a Lua project in the future and make something cool. Make Angry Birds or World of Warcraft apparently, because those are written in Lua, or at least partially written in Lua. But yeah, so I'll let you. I'll if I see you next week, I might see you next week. If so, I'll be doing Game Maker. If not, I'll be returning 2 weeks from now to do a playthrough of Greyhack, which should be fun. And then we'll touch base next week and kind of figure out the plan going forward. But I think after April's over, I should hopefully be more consistent with my streams, doing once a week, still at the same time, roughly the same time frame. Streaming for at least 2 to 3 hours, maybe 4, I guess, if I run into like bugs and stuff. But it is what it is. So yeah, I think that's pretty much all I have for today. So thank you all so much for watching, and I'll real quick one last time shout out that I am streaming on both YouTube and Twitch. So you can find me on Twitch at Software with Thomas, and also on YouTube at Software with Thomas. Yeah, and especially right now on Twitch, it doesn't seem like my VODs are staying for long because my Twitch account's still pretty new. I don't know if they're staying at all, but all of them are still on my YouTube channel. So if you want to see any of my past streams, my Godot streams where I made some 2D and 3D games, my previous stream where I did a Wordle clone in JavaScript and HTML, you can find those on my YouTube channel. Feel free to drop a subscription, drop a like, all that good stuff. It really helps out because you know what? I'm still new to the streaming thing. I'm still figuring it out. So this is still kind of my first month of streaming, and still kind of, getting adjusted to all of it. But I'm having a good time. Looking forward to doing some cool projects here in the future. And especially now that we know another language, I know Lua now, at least the very basics of it. Maybe we'll do some simple Lua project in the future. Make a command line tool, make some script for something. I don't know. I have to figure out what all cool stuff we can do with Lua, but it seems like a pretty simple language, and curious to see what we can all make with it. So that's all I have for today. So thank you all so much for watching, and until next time, I'll see you. Peace. Have a good week, and I'll see you maybe next week, maybe the following week. Bye, everybody. Go learn some Lua. It's a pretty chill language to learn.